Number 1, graph the function y equals x squared plus 6x plus 4. This is a quadratic function in standard form. So I can find the vertex using the formula x equals opposite of b divided by 2a. This will give the axis of symmetry. We have a equals 1, b equals 6, and c equals 4. C gives us the y-intercept. 1, 2, 3, 4. Now let's go back and find the axis of symmetry and vertex. So we have the opposite of 6 divided by 2 times 1 equals negative 3. X equals negative 3 is the axis of symmetry. And our parabola will be symmetric with respect to the axis of symmetry. Let's plug in negative 3 to get our vertex. Negative 3 squared plus 6 times negative 3 plus 4. This will give us the y value for the vertex. 9 minus 18 plus 4 is negative 5. Vertex is at negative 3, negative 5. Let's correct that little glitch there. And double check 9 minus 18 is negative 9 plus 4. It looks good. Okay, vertex at negative 3, negative 5. 1, 2, 3, 4, 5. Since we're symmetrical with respect to the axis of symmetry, we can plot a point over here. And last comment, since our a value is 1, we know we can go over 1 up 1 from the vertex, over 1 up 1 for additional points. Can also go over 2 up 4 because 2 squared is 4. Over 2 up 4. And then you can make your parabolas. A little challenging to make it on here. This is a sketch. There we go. Second problem, identify the vertex, axis of symmetry, maximum or minimum value of the function, and the domain and range of the function. All right, let's go with vertex first. What we have is a quadratic in vertex form. This is a quadratic function in vertex form. So now our vertex will be 2 and negative 12. Vertex form has x minus h plus k, or hk is your vertex. Just a little refresher there. All right, now the axis of symmetry goes through the vertex. It is a vertical line. X equals 2. The maximum or minimum value. This parabola opens down. So it has a maximum value. vertex is located. And that value is y equals negative 12. So the function's maximum value is negative 12. Domain and range. Domain of a quadratic is all real numbers. Can be used for x, and the range, highest value of the function is negative 12, and we're going down to negative infinity, so including negative 12 with a bracket to negative infinity. And let's switch that in the order. Negative infinity to negative 12. For the range. Again, it includes negative 12 at the maximum. All right, number 3, sketch the graph of the quadratic function and the axis of symmetry, state the vertex, and give the equation for the axis of symmetry. So we have a function, quadratic function in vertex form. So the vertex is going to be negative 1, positive 3 for our xy value. Let's make that larger. That's putting the axis of symmetry. Axis of symmetry will go through that point. So we have x equals negative 1. And let's make our axis of symmetry go through there with a thinner line. Okay, we've dealt with the axis of symmetry and the vertex. Let's get the equation for the axis of symmetry. Got that x equals negative 1. And we need to sketch this graph. It's going to open downward with that negative. And the 2 means instead of going over 1 down 2, we need to go over, instead of going over 1 down 1, we need to go over 1 down 2. On both sides of the vertex. Instead of going over 1 down 4, we need to multiply that 4 by 2 and go over 2 down 8. Sorry if I say go over 1 again. Go over 2 instead of going down 4. We need to double that to down 8. And that will be enough points to sketch the graph. We observed immediately that it was, or you could have observed immediately it was opening down. Okay. There we go. Number 4, factor the polynomial expression, x squared minus 11x plus 10. First, look for a greatest common factor. There is none. So this trinomial, we can attempt to factor into 2 binomials, x and x. Will multiplies to 10 and adds or subtracts to negative 11. That'll be a negative 10 times a negative 1. You can double check this using multiplication, distributive property, box method, or FOIL to bring you back to the original polynomial expression. Number 5, factor the polynomial expression. See that begins with a number other than 1 for our a value in this quadratic, so we're going to do the AC method. 3 times 4, a equals 3, c equals 4, so AC equals 12. with factors to positive 12 and adds to positive 13, positive 1, and positive 12. So we're going to break up the middle of this polynomial function to positive 1x plus 12x. Refresher on the AC method. Bringing down the first term, 3x squared. Bringing down the last term, plus 4. So the rewritten polynomial expression now has 4 terms. Factoring the first 2 terms together, then the final 2 terms together, factoring out the greatest common factor. This has an x, leaves you with a 3x plus 1. And this has a positive 4. And it will also leave a 3x plus 1. Remember, what's in parentheses should match. So this now factors to 3x plus 1. From the beginning, that leaves us with an x. And from the back, it leaves us with a plus 4. So our other factor is x plus 4. This is factored completely, and you can check it by using box method, FOIL, or distribution property. Okay, next problem. Factor by first factoring out the greatest common factor, which you should do with every factoring problem. Attempt to factor out a greatest common factor. Common factor is 5. Make sure that 5 is included in the final answers. That leaves 4x squared minus 8x minus 5. Now, because of that 4, I'm going to use the AC method. AC equals negative 20. 4 times negative 5, what multiplies to negative 20 and combines to negative 8. That will be a negative 10 and a positive 2. Let's break up this middle. Negative 10x plus 2x. Keeping everything else exactly the same. 4x squared in the front, minus 5 in the back. And we need this 5 to be a part of our polynomial expression because it was the first factor. Now factoring these first 2 together, greatest common factor will be a 2x. That will leave a 2x minus 5. Factoring the back pair together, they have a 1 in common, so positive 1 gets factored out, and that will leave a 2x minus 5. So each term, or each result has 2x minus 5 in the parentheses. You expect those to match. What is remaining? 2x plus 2. That becomes the other factor. And what are we keeping? The 5 at the beginning. So this is now factored completely. Okay, number 7. Solve the equation. We have a quadratic equation, x squared plus 9. There's no b, so I'm going to factor using square root method. Subtract 9 from both sides. X squared equals negative 9. Take the square root of each side. X equals the square root of negative 9. And that will be the positive square root or the negative square root. Having 2 possible solutions here. All right, the square root of negative 9 will equal 3i. And I equals equals the square root of negative 1. So x equals, if you want to write this out, x equals 3i, the solution, one complex solution. The other complex solution is x equals negative 3i. Number 8, solve using the quadratic equation. And you should be able to do this from memory. So let's write the quadratic equation. Opposite of b plus or minus square root of b squared minus 4ac. Okay, and all of that is divided by 2a. Denominator is 2a in the quadratic formula. And this will give us our x values for our solutions. Okay, now let's determine a, b, and c. A is 6, b is negative 2, and c is negative 5. Substituting those in, I'm going to substitute a negative 2 for b, and then we want the opposite of it, plus or minus square root. Second time we need to plug in a negative 2 for b. That's going to be squared minus 4 times, and we're substituting 6 in for a and negative 5 for c. Extend our radical symbol. 2 times a, which is 6. So you see 1, 2, 3, 4, 5 substitutions. Always make sure you have those 5 substitutions into your quadratic formula. Order of operations, 2 plus or minus the square root of 4. A lot of students will make this be a negative 4. That's always going to be a positive value. This turns into plus 120 divided by 12. Okay, 2 plus or minus square root of 124 over 12. It's going to be 2 plus or minus 2 times the square root of 31, because that factored into 4 times 31, and the square root of 4 is 31 over 12, and that reduces to 1 plus or minus the square root of 31 over 6. And those are the solutions. Number 9, determine the end behavior of the graph of the polynomial function. So to determine the end behavior of a polynomial function, we have to look at the leading term. Since it's positive, the right end goes down. And since it has an odd degree, the ends go in different directions. All right, so as x approaches negative infinity, the function on the left is approaching infinity. Let's make a correction. The right end is going up whenever we have a positive. And I hope you caught that. That positive 5. Positive always means the right end goes up. Now the odd degree makes them go in different directions. So as x approaches negative infinity, the function approaches negative infinity. That's the left side. And as x approaches positive infinity, that's the right side. G of x is going up. It's approaching positive infinity. Okay, we have 1 or 2 more of these where we can look at that again and make sure I didn't confuse you. Number 10, determine the end behavior. Okay, look at the leading term. Again, positive, so the right side is going up. Positive 5, right side goes up when it's positive. Now we have an even degree. Trying to get that in red, it's not cooperating. There we go. Even degree. So both ends go in the same direction with an even degree. Previously, odd degree, 9, they went in different directions. Even degree, they go in the same direction. So on the left-hand side, as as x is approaching negative infinity, that's the left-hand side, then g of x is approaching, going up, positive infinity. And on the right-hand side, as x approaches positive infinity, the function is also going up. The function is approaching positive infinity. Okay, so now we're back on track. And one more, number 11. Determine the end behavior. So let's look at the leading coefficient. And what we didn't check for on the first two is make sure that this is in standard form. 6 is the highest degree, so this does represent the leading coefficient. Let's go back. Number 10, 8 is the highest degree, biggest exponent, so that is the leading coefficient. It's in standard form. 8, then 4, then 1. And double checking number 9. 9 is the biggest or largest or greatest exponent, so that is the proper term to select as the leading and get our leading coefficient. All right, back to 11. So negative 4x to the 6 is the first term. Negative 4 is the leading coefficient. So we have a negative, that means the right side is going down. Negative means the right side is going down. Then look at the degree, it's even. Both ends go in the same direction. So the right side is going down from the negative 4. Both sides are going down because of the 6, an even number. All right, now, left-hand side, x is approaching negative infinity. And what's happening when x approaches negative infinity? The function is going down. G of x is approaching negative infinity. Looking on the right-hand side where x is going towards positive infinity, the function is also going down on that side. So the function g of x is also approaching positive infinity, and that's our end behavior. What's happening on the two ends of the polynomial function. Okay, good to go. Number 12. Write the polynomial expression in factored form. We always want to look for the greatest common factor. Each of these has an x squared that factors out. That will leave x to the second minus 6x minus 16 after factoring out. You can always double check by multiplying each term with distributive property by x to the second, and it will bring you back to the original polynomial. Now let's see if we can factor our trinomial into two binomials. We'll multiply to negative 16 and adds up to negative 6. It's going to be a negative 8 and a positive 2. And you have to keep that original factor that we factored out as a part of our answer. Let's put equal sign there. Okay. That's as far as we can go. It's in factored form. Very good. Number 13. Write the polynomial function in factored form. Okay, let's begin by factoring out the greatest common factor. Looks like each term has x squared, and additionally each term divides by 4. And with the leading coefficient being a negative, let's factor that negative out. So negative 4 and x squared all get factored out. It's going to dividing each term by negative 4 and by x squared. The first term remaining inside will be x squared. Multiplying that back together would bring you back to negative 4x to the fourth. And then next we would have a plus x That would come back to negative 4x cubed if we multiplied it out. And lastly, negative 20. Negative 4x squared times negative 20 would be the 80x squared. Okay, let's see if this trinomial can be factored into two binomials. 1 multiplies the negative 20 and adds the positive 1. That's going to be a negative 4 and a positive 5. X minus 4, x plus 5. You can use box method, FOIL, or distributive property to check that. And we need to keep our negative 4x squared as one of the factors. Okay, so this is factored completely. And your instructions will usually say factored in completely, and if they don't, you need to factor completely. Always factor completely. Always factor completely unless told otherwise. Final problem. Find all roots. Roots, zeros, they're synonymous. So the equation is set up, the polynomial equation is already set up to equal 0, so we don't need to manipulate anything to make it equal 0, but check for that. Now, how do you want to solve this? We can try to factor it. One way we can factor is with a synthetic division. Get us started. Let's look for some rational roots possibly. What factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, positive and negative 6. Since it starts with a 1, we don't need to look for any additional rational roots. Now, notice you only have plus signs. So inserting a positive number will not make this equal 0. Only a negative number will make it equal 0. So we only need to try negative 1, negative 2 out of our choices, negative 3, and negative 6. And at most, we will have 4 roots. So let's use synthetic division starting with negative 1. Okay, so 1, then 5, then 7, then 5, then 6. Looking at the exponents, 4, 3, 2, 1, so nothing skipped. 1, 5, 7, 5, 6. Good. Bring the 1 down. It's a negative 1. Combines to 4. It's a negative 4. Combines to 3. That's a negative 3. Combines to 2. It's a negative 2. That didn't work. Gonna try negative 2. 1, 5, 7, 5, 6. Bring the 1 down. Negative 2, 3. Negative 6, 1. Negative 2, 3. Negative 6, 0. Good. So I have one root is x equals negative 2. Now I'm going to show you a creative way to continue without using synthetic division. You see a 1, a 3, a 1, a 3 with these 4 terms. And you know this is x cubed, this is x squared, this is x. I'm going to rewrite this. X cubed plus 3x squared plus x plus 3. Because of that pattern, 1 to 3 and 1 to 3, we can consider factoring by grouping instead of continue with synthetic division. So the first two terms will factor into x squared and then x plus 3, excuse me. And the back two terms will have a positive 1 factor out and have x plus 3. And then this will go to x squared plus 1. Where is that coming from? That and that. And in parentheses, x plus 3. The root we get from this is x equals -3, because -3 will make that 0. And x squared plus 1, the root you get from x squared plus 1, make that equal 0. It's going to be plus and minus I. Why? Because you're looking at x squared equals -1. So with 4 possible roots, we have them all. There's a real root, and 2 complex roots. Okay, that is the first part of this semester exam for Algebra 2. I will see you soon for part 2. Thanks for watching.